Hello, welcome to Body Talk Bukog Edition, the show that explores the incredible engineering of the human body. I'm your host, Dea.
And I'm Vaughn, and it's great to have you with us today. We're getting back to the basics and talking about the very framework of our bodies.
That's right, we're diving deep into the skeletal system. Now you might be wondering, bones are just the dry, non-living things inside your science classroom or your science laboratory. But the truth is, our skeleton is living, dynamic system that is absolutely important to our existence. It is so much more than just bag of bones.
Exactly, right? Without it would be nothing but more than a puddle of soft organs on the floor. So today we're going to take a journey through this amazing structure. We'll cover the incredible jobs of our bones and do for us every second. Look at the different types of bones and take a quick tour of the major players for our skull to your toes and even explore how they manage and to repair themselves.
That's right. It's a really fascinating topic and it really gives you a new appreciation for what's going on under your skin. Now, partner, let's ask the big question. What do our bones really do for us beyond just holding us upright?
That's the perfect place to start, partner. Before we get into naming all 206 bones of the body, it's crucial to understand the why. No? The why our skeleton is a master of multitasking, performing at least 5 critical functions of the body that keep us alive and moving.
Alright, first and probably the most obvious one, partner, we have support. Our bones are like the steel frame of a building. It is composed of the internal framework that supports our body. For example, the bones in our legs support our trunk when we stand up, and our rib cage supports the thoracic wall. And also, it cradles our soft organs inside our body.
Yeah, that's right. So, and in that rib cage brings us perfectly for the second function, protection. So, our skeleton is our body's personal bodyguard. So kung naamang kay isa ka kasikat na actor, di ba? Naman yung kay bodyguard. So, ina natong skeleton sa to ang own bodies. So, think about it. The fused bones of the skull provide a snug enclosure for the brain. The vertebrae wrap around the spinal cord and that the rib cage shields the vital organs of the chest, like the heart, the lungs, and it's an incredible natural armor.
Wow, that's actually really amazing for a skeletal system, partner. Next on the list is allowing movement. Skeletal muscles are attached to our bones, and our bones serves as levers for these muscles, partner. Now, here's a little thought experiment for those listening. Imagine your bones suddenly change into cartilage or something much more flexible or softer than bone. Now, partner, what if you were running and this change suddenly took place? What do you think would happen, partner?
Dagma jud ka, partner.
That's true, partner. Because without the rigid framework to pull against, muscle contractions would be, entirely useless.
Wow, that's a great way to think about it. The fourth function is a bit less obvious. It's storage. So bones are storehouses for minerals, right? There are chemicals inside it, and the most important one is calcium. A chemical amount of calcium needs to be present in our blood at all times for our nervous system to transmit messages and for our muscles to contract. Our bones act like a mineral bank account and making deposits and withdrawals of calcium to keep that level, just right.
Wow, that seems pretty less obvious, partner, rather than the other ones we've mentioned. And finally, partner, we have a function that may surprise a lot of people. It actually forms blood cells inside the bone. This process, also known as hematopoiesis, happens inside the marrow of certain bones. So our skeleton isn't just a structural frame, partner. It also actually serves as a factory.
That's right. Support, protection, movement, storage, and blood cell formation. Wow! So amazing. These are the foundational pillars that make the skeleton so critical for our body. So now that we know what it does, how is such a strong and versatile structure actually built?
Yeah, that really makes us think, partner. How are these bones actually built? Well, that question, partner, leads us to bone architecture. Skeleton's diverse functions are only made possible because these bones are masterfully engineered with different materials and different shapes, each one suited perfectly to do their job. At a basic level, partner, all our bones are made up with two types. First, we have the compact bone.
Yeah, right. And the compact bone is exactly what it sounds like. It's dense, smooth, and very solid. It forms a tough outer layer of our bones, but inside that we often find the second part, the spongy bone. This type is made up of small needle-like pieces of bone with lots of open spaces, which helps make bone lighter without sacrificing too much strength.
Yeah, that's right. And just as there are different types, partner, there are also different shapes. And they are generally classified into four groups based on their shape. The first is long bones, like the humerus in our upper arm, partner. These are typically longer than they are wide, and they are mostly made of compact bone, built for leverage and movement.
Yeah, that's right. Then, if there's long bones, you have short bones, which are
right.
generally cube-shaped like the talus in your ankle. And we also have the flat bones. And the flat bones like the sternum or the bones of our skull. Now, this is where it gets really clever. They have two thin layers of compact bone sandwiching a layer of spongy bone. That structure connects directly back to the protection function we talked about ganina.
That's right.
It's the same design principle as a bicycle helmet, a hard outer shell with a shock absorbing inner layer. It's perfect for protecting vital organs like our brain.
Wow, partner, that actually makes perfect sense. And the last category for everything that doesn't quite fit into the mold, we have irregular bones. The vertebrae in our spine are the classic example here. Their complex shapes are perfect for their specific jobs of protection and support, particularly protecting the spinal cord. And this combination of shape and composition is what allows each bone to do their function properly. Now, let's talk about the building blocks and go on a quick tour, starting with the body's central axis.
Alright, let's put on our tour guide hats, or you can say glasses. The skeleton is divided into two main parts. Let's start with the axial skeleton. The axial skeleton, which forms the core, the longitudinal axis of the body. It's made up of three main parts, starting at the top with the skull.
The skull is formed by two sets of bones, the cranium and the facial bones. Its most important job is to enclose and protect the fragile brain tissue.
Moving down from there, we have the vertebral column, or spine. This is the body's central support extending from the skull down to the pelvis.
That's right.
It surrounds and protects the delicate spinal cord, but it's not a rigid rod. It's separated by intervertebral discs. And get this, in a young, healthy person, these discs are about 90% water, which I know is very amazing, right? Makes them spongy and compressible. That's why we are very flexible. So exactly, but as a person ages, the water content of the disc decreases and they become harder and less compressible. It's one of the reasons people can get a bit shorter and stiffer over time.
The final part of our axial tour, partner, is our thoracic cage. This is your rib cage, partner, made out of your sternum, the ribs, and your thoracic vertebrae at the back. Its primary role is to form a protective cage around your heart, lungs, and important blood vessels.
And not all ribs are the same, you know that?
No, partner.
The first 7 pairs are called true ribs because they attach directly to the sternum via costal cartilages. And the next 5 pairs are called, if they are true, they are called false ribs. So false ribs which attain indirectly or not at all. And the last 2 pairs of those are called the floating ribs because kung imo na siyang visually see, they're floating, and because they don't attach to the sternum whatsoever. So that's our core. But what about the parts that let us interact with the world?
For that, we turn to the appendicular skeleton, partner. This is everything else, the limbs and the girdles that attach them to the axial skeleton. Let's start with the pectoral or the shoulder girdle. It consists of the clavicle and the scapula, partner, and it connects our upper limbs to the body, basically our arms. What's amazing here is the engineering compromise. The shoulder girdle is very, very light and allows for an incredible, exceptionally free range of movement. That's why we can move our arms this way or maybe that way or maybe all around or something.
But is there a trade-off, right? There's a trade-off, right?
Yeah, there is actually a trade-off. This incredible mobility rather costs for its stability. It's very easily injured and it's not very stable sometimes. But it's a fascinating balance actually.
All right. And those upper limbs exactly include the humerus, the radius, and the ulna. And then the complex bones on the hand, the carpals, metacarpals, and the phalanges.
Huh. Moving down the body, we have the pelvic girdle, formed by two coxal or hip bones. This is an incredibly strong partner because it has the very important job of supporting our total body weight.
Attached to the pelvis are the lower limbs, and these bones are absolute powerhouses. You have the femur or thigh bone, which is officially the heaviest and strongest and longest bones in the body. Below the knee are the tibia and fibula. And finally, the foot, which contains the tarsals, metatarsals, and phalanges.
This is an incredible system built for force and motion, partner. But with great force comes with great risks, and sometimes even those masterfully engineered structures or bones that we talked about earlier, they can actually break or fail, partner.
That's very true. Despite their amazing strength and their rigid structure, bones can break, which is called a fracture. For kids whose bones are more flexible, a green streak fracture is common. It is an incomplete break, and the name of the perfect analogy, it breaks much like a way the green twig breaks.
Wow, that sounds really hurtful. On the other hand, in older people whose bones tend to be much more brittle, partner, a comminuted fracture is much more common. This is when the bone breaks into 3 or more fragments. But the most incredible part is not how they break, partner. It's actually how they heal. The body launches its amazing internal emergency response almost immediately, partner.
Wow, it is really a story in 4 acts. The Act 1, the hematoma formation. The moment the bone breaks, blood vessels are torn, right?
Yes.
And the blood-filled swelling, the hematoma forms. This is the immediate alarm bell, or like when there's a fire, you have the fire alarm.
Yeah, that's right. And Act 2, the cleanup crew and the construction of temporary scaffolding. The body sends in cells to clean up the dead tissue, and then someone special comes in, partner. A fibrocartilage callus forms. This is like a soft, natural splint that closes the gap between the broken ends. For example, partner, when there's like danger or maybe the flood incident from a few days ago, there are temporary reliefs, right? It serves as like immediate response or some sort of temporary, let's say, relief for the people.
You're absolutely right. And now let's move on to Act 3. The Act 3, permanent reconstruction. Over the next few weeks, a bony callus forms. More bone cells move in and replace that flexible splint with a much sturdier one made of spongy bone.
Right. And the final act, and maybe the most amazing part, partner, renovation, or we call it bone remodeling. For several months, the body remodels that bony callus, partner, shaping it in response to the stresses placed on it until a strong, permanent patch is formed. It can be as good as new or maybe even stronger than before, partner. And it's a really, really good example of how the body heals itself.
This has been Group 4. Thank you for much tuning in Body Talks Bukog Edition as we explored the amazing skeletal system. Until then, stay curious.